Hello, Internet. A few weeks ago, I was challenged by Matt Gibson in the comments to make a worms style terrain deformation thing. So I'm pretty sure that Worms does their terrain deformation and all of that using per pixel collision logic and all of the fun that that has to do with it. We're not going to do that. But what we are going to do is we're going to do something similar. We're going to be working with we're going to be working with 2D voxels. And so it's probably going to be a number of episodes to get this done. But the idea is we should be able to do 2D voxel terrain. We're going to be using marching squares, which is a variant of the marching cubes algorithm, which was pretty much used everywhere for voxels. And it's just a way to make smooth meshes out of voxel terrain. So what we're going to be doing is we're going to be starting with just creating a quadtree, which is it's a variant of the octree we made for our unity graph, and we're actually going to be basing it off of the octree. I've got the code here, and it's just renamed, honestly. There's no actual changes. It's just everything was renamed to quadtree instead of octree. But the idea is the same. So what you do is you take a square, and you divide that square into 4 smaller squares that take up each of the corners. And you just keep doing that recursively until you get whatever depth you needed. And so the advantage of a quad tree is it's only 2D. It's just a quad. It's just a square. Compared to an octree, which is going to be in 3 dimensions and is going to be dividing cubes. So really, we just need to squash it and get rid of one of the dimensions, which shouldn't be too hard. So I'm going to try to just keep this episode constrained to that. And then we're going to expand it into the next few episodes and actually start building a mesh out of this quad tree that we build. And then the last step is going to be actually blowing it up and putting holes and stuff in it. So we'll see where we get. I imagine this one will go smoothly, and then all the other ones will crash and burn. But you never know. This one will probably be the same as all of the other ones. So we're here. This is identical to our original octree. If you want to see that episode, I'll probably stick a card or a description link or something in it here. I don't know what it will be, but it'll be somewhere. I hopefully it's obvious. If not, oops, future me screwed up. But anyway, what we have is we have an index, which is kind of where in each of our subtrees, or how this works is every node, so you have a node and they're just kind of tiered. So the top node is going to have a list of all of the nodes directly beneath it, and each of those is going to have a list of all the nodes directly beneath that, and so forth. So our indexes, all they were doing is actually showing where to go. And we were using 3 bits because we needed X, Y, and Z. Now we only need 2. So I can kind of cut this down, and we can actually do a top left. So we're going to start in the top left, then we're going to move around like that. So then we're going to go top right, and then where was the next one going to go? Bottom. Do we want to go clockwise around it, or do we want to do some sort of staggered pattern? I think, actually, we want to do a staggered thing. And I'll show you why in a second. So the idea is our second bit, our furthest to the left bit, we only have 2. So one of these hands is going to be our x-axis. It's going to be our left and right. And one of them is going to be our up and down. And so really the idea is you either want to say, if like both of these are false, then you want to say this is, I think we're saying top left. So say this hand is our top and bottom. If this is false, then we're saying it's the top. And if it's open, then we're saying it's the bottom. That's sort of the logic we're going with. And we're doing the same for left and right. So if it's false or 0, it's going to be on the left is what we're saying. And we actually want that to be consistent, which this isn't. What did I do? So I made This is all screwed up because it's not aligned, so it's a little bit harder to read. So let me, oops, fix that quick. There we go. So I lied. Our rightmost bit, this is 0 here, the highlighted 0, that is our X. It's either going to be left or right. No, that is our Y. It's going to be either top or bottom. 0 is top, 1 is bottom. And then our leftmost bit is either going to be left or right. So 0 is left and 1 is right, which means this is wrong. I should really start looking at this before I start explaining it, because that was also wrong. There we go. That's better. So our 1 bit is X, like I was originally saying. This is probably going to be a mess. All right. Anyway, our 1's bit is going to be either left or right. If it's 1, it's right. If it's 0, it's left. Our top and bottom are going to be our 2nd bit. And that's either going to be top if it's 0 or bottom if it's 1. So this doesn't really specifically matter. The only thing that this really affects is how we're actually going to find, or where things are going to be positioned in those subtrees. So that went less smooth than I had hoped, and honestly, I probably did it better in the first time we were doing it when we were actually coming up with it. I don't know why that's like that, but anyway, here's what we have. We have a list of indices like that, and now we have a way. What we were doing is we were subdividing each node, so nodes could subdivide themselves. And I think I actually like this idea because since we were doing it this way, this actually gave us a really cool thing because we could choose not to subdivide some of them, and that actually gives us sort of a sparse graph. And so the cool thing there is if there's no data in some particular corner, so you have a giant like hole in the middle, you can not fill in that part of the map, and just, if there's nothing to store there, there's no reason to fill it out and take up all that extra memory for it. So if it's a sparse graph, you can actually do that. If it's complete, that's not an option. So by doing this subdivide here, we can actually specifically either subdivide it or not, and prevent that or not. So what we need to do is handle our X and our Y. We're still going to be working with vector 3s, even though, are we going to be working with vector 3s? I think we could probably work with vector 2s. We're going to work with vector 2s. Yeah. So let's plug in that and change all of them to vector 2s, because it's a 2D graph, so we only need X and Y. And unless I'm very much mistaken, a vector 3 can be translated into a vector 2. If I'm wrong, it might be a mistake to do this. Let's find out. What's the easiest way to do it? Vector 2 test is equal to position. Okay, that seems to work. So as long as it's fine with that, I think we should be good, because all we need to be able to do is take our position and translate that into a 2D vector. And then we're just using a 2D vector here because we only need them, and it prevents any misconceptions. So what we need to do is actually pull out this new position.z. That's not needed. And then we need to change the logic here. So what this is doing is when we subdivide, we need to actually reposition each of our nodes in our tree. And so how this is doing it is actually moving our position each of our positions a little bit over, so a quarter of the total size. And the reason it's moving a quarter is because you're already halfway across, and so you want to move halfway into one of the other sectors, so you kind of get the center bit. So you move half or a quarter over, because then you have the other 3/4 that you didn't want to move. That then also, this isn't working. My descriptions are awful. I'm sorry if this is confusing. Um, hmm. There's got to be a better way to explain this. Like, if I actually knew what I was talking about, that'd probably help. Let's see here. What we want to do is we want to change the logic here so that it's actually looking at the proper bit. What this logic was doing is it's actually going through and comparing, or it's finding the bit at a specific point and then seeing if it's true. So this is looking at our second bit and seeing if that's true. And this one is actually looking at our first. We had a 4 there as well, which would be looking at the third bit. We don't need that because we only have 2. And this is related to this. So it's really, the interactions are actually related based on this. So top left is going to be 0, or left rather is going to be 0, right is going to be 1, and then bottom is going to be 1, and top is going to be 0. So that means this is going to be our x, it's going to be our left and our right. And so if it's true, that means we want to go to the right, right? Yes, yeah, which is going to be actually positive. And we want to go to the left if it's negative, or if it's 0, which we're doing here as well. And then a 1 was also negative. So this is actually backwards. And this is, so it's important to point out, this is just an implementation detail. It doesn't have to work. None of this is specific to how this has to work. You can change this if you want to. All we need to do is be able to actually generate those 4 additional nodes. And I believe we do that. So we create the new positions, and then we create the size of half of what it was previously. So it shrinks it down and puts it in each of those sectors, and then we're good. So that should be identical to where we were. The only difference is now we're doing it over vector 2, and we've tossed out that z vector. Speaking of tossing out the z vector, we can get rid of that and put those in. So we just switch everything back to our 1 and our 2. And then we want to use vector 2's again. And that should be that. I think everything's there. I just check quick. We need to switch our position to vector 2 again. And then that should be everything that we need to do. So the only other bit that we need is we need to actually go in and create a component. This is not, or this Quadtree has no relation to Unity whatsoever. The only thing it does have is it references the Unity engine, so it can pull out those vectors. But we don't need that, and I'm actually gonna delete this Win32 safe handles. I don't know what that is, and I don't know why it's there. That was kind of weird. Anyway, we didn't need it, so it's gone. We've got our Quadtree now. And so what we were doing to actually tie this back into Unity is we were creating a Octree component. We're going to do the same thing for our Quadtree and create a Quadtree component. And the idea is we'll just display the Quadtree. So, can get up here, do a new Quadtree component. Let's actually create an empty game object. Do that, plug that in, and now let's open this. It's going to be empty, but we can just copy and paste most of this. And now we have a Quadtree component inside of Unity, which theoretically should work. It's not using our Quadtree, so let's actually plug that in. One of the issues with this is that it is actually bad. So this implementation is kind of rushed, and we're not here to fix it. But what it does is it draws your Octree or your Quadtree. But the problem with it is it actually regenerates it every single frame, which is slow as heck, but it works, and that's what counts. So the advantage of generating it or regenerating every time is that as you change it, it dynamically updates, and there's nothing we have to add. There's no extra logic we need to do to make that work. The downside is it is ridiculously slow. So what we need to switch this out for our Quadtree node and a Quadtree like that. Spell it correctly. And is there anything else that we need to do? I don't think so. The only other thing that I do want to do is actually, I think we might be there. Let me just check if there is a draw. I don't think there's a way to draw a rectangle, so we're just going to be stuck drawing our cubes. So the only thing I'm going to change is I'm not going to draw a vector 1 anymore. I'm going to draw a new vector 3 of 1, 1, and 0. And so the advantage of this, just so we get a little bit of depth, we'll do a 0.1. But the idea here is we want it to look flat. And hopefully this gives us a flat look. So we should be able to open this up now and plug that in, and we are getting what looks like a quad tree. Huzzah! So it is working. There's one issue that I'm noticing. It's dividing everything by a half, and so our size is also shrinking, which is kind of weird because it's also shrinking on the z-axis, which we don't. I didn't actually expect that to happen, but the cool thing is that we can now build a grid. So what you can see is this white outline here is our first. That's the top of our tree. That's the full node. And then you have the second iteration. What are you doing there, Unity? Oh, so we've got the second iteration, or our depth of, I think, 0 is how our actual implementation works, which is a little bit wrong. But it cuts it here, 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 and here. So we get those 4 grids. And then each of those get cut into those slightly darker blue lines. So down here, across there, down that way, and across that way. And then that final grouping is our depth of 2. But we can crank this up and do like a depth of 5. And you can kind of see how we get significant amounts of depth here. So the cool thing about this is that the implementation, we didn't really get into it, but it's pretty much identical to what we did with our octree, which is good because it means that if one of them's broken, we can fix both of them. The downside is if one of them's broken, the other one's broken, but that's irrelevant because otherwise we just have 2 pieces of code that are totally separate and we have to maintain separately. We might even be able to abstract this even more and actually get it so that we can have a single class that can do any number of dimensions, but that might be wishful thinking. And really, it's kind of outside of the scope of what we need. I don't think you need anything more than a 3D tree like this. I don't need it. I'm sure there's uses for it, but I don't know them, and I don't particularly need them. So what we have here is our octree. And so our eventual data is going to end up in each of these nodes down here. And so that's how everything is going to fit together. Eventually, each of those little squares is either going to be a true or a false value for our terrain to be there. And then we're actually going to take that and draw a mesh with it. Or that's the idea. So I think that's it for this video. I don't want to go too fast with this because I honestly don't know what I'm doing. So I kind of want to implement things at a pace where I can get them set up and then kind of figure out where are we going next before, instead of just jumping over hoops and just kind of running down the course, because I think we'll probably end up in a bad spot if we do that. So the next step is going to be to draw a dynamic mesh that actually fills this out. So we're going to need like a random generator to actually add data to each of these nodes. And then we're going to need to actually run a mesh generation algorithm to actually build that mesh. We already have that mesh generation. We already did a video on that. So we should be able to bring that in and use that to solve this initially. But I don't think that's designed in a way that we can continue to use it as this gets more complex, because this is going to get it's going to get more difficult than this. So there's going to be some interesting things, and we're not going to do any smoothing at all initially. There's not going to be any optimizations in this, so it'll probably be awful. But then we can smooth it out, and then we can work on actually destroying it and do some performance tests and actually figure out what's going on. But that's it for now. So if there's any feedback you guys want to leave, if there's anything you want me to improve, let me know in the comments. I'm always open for it. This project is from a comment. So if you guys have any ideas, leave them there and I'll get to them hopefully within a day or so. But that's it for now. So see you, Internet.